Okay, we will continue now from where we left off. In the last video we ran our building measure, so it went through. I think the last one errored. Sometimes happens if we right click and because this is like a new Houdini session, and if it finds the files, it will pass them. Oh, because it's not completed, I think it will not. Okay, then I'm gonna kill this because I don't want to overwrite the files, but it did went through. If you cook one of these wedges, and if you have a look, the files will be there. I think there's supposed to be one more because we may ask for 10. I think the last one crashed. Not sure why. We can test something like this. If I click on this guy, this is the last one. This may end up in a crash like the last time or not. Let's have a look. So then if I go in my building generator, I'm on manual at the moment, and probably I know that one crashed, so I want to go down from here a little more cautiously, right? So before all the booleans and stuff, so let's go with the proxy until the proxy first. Okay, the proxy is good. Let's go down, maybe disable these UVs for now. The floor, okay, it's good. This is fine. Let's go check the shells. The shells are a bit suspicious here. Let's have a look why. The square looks small. This is the floor, right? Yes, here we get the proxy. Okay. Oh, how interesting. This didn't happen in the other ones. Our lines got stuck inside. Is it purely because because the boolean didn't work? Okay, this happens sometimes. So there's not much really you can do. You see our boolean cutout sections in other versions, but in this one it kind of failed here. Sorry, I was supposed to empty these areas and it didn't happen. Because this is supposed to be subtract, and sometimes this happens. I wonder why. I think it's because we have some empty gaps. It could be like too much overlapping maybe here. Let's try to remedy that. Let's try to fix intersections at this level. Let me see, here is it's a bit more, I guess, closed, because when we extrude, this also looks clean. I'm not sure. Oh, because when we do the poly extrude, things may go overlap each other, so this kind of makes a better clean. All right, it's good to know. And now actually, yeah, that was the case. Okay, something I didn't encounter before, but now I did. Let this cook now. Doesn't explain why it crashed though. It's maybe a different thing, but let's keep going down. I'm gonna save this and let's go down outbuilding. And I'm gonna if it cooks, I'm gonna right click this and manually save as my 9th iteration, so we don't have to, because it's the same thing. So we don't have to recook the, which should be exact same. Like right click on the I can't show you now. Right click on the tops node and then recooking the whole thing, but sometimes that kind of forgets and starts doing it from the beginning. I think if you change parameter, I don't exactly know how it works, but sometimes it just, I think, checks the files if the files exist, but I don't know if the file, okay, see, it crashed again. Building generator for each and 7 past 33 boolean 9. Okay, we need to find boolean 9 past 33, but this is a little random. Could be based on some updates, build versions. It's very hard to track. That's why if I'm not happy and if I need exactly 10 variations, I'll just, it cook like 8 of them, fine, and I'll show you the buildings now. And one failed, so not really much we can do unless you just shift things around and try to find what caused the issue. This is the last one. Let's have a look at the 8 successful random buildings we managed to cook for now, and then proceed with 8 unique buildings. You can do like 20, cook it overnight, see how it goes. Let's open up a file node here. Remember, because we baked them based on building seed, right? 0 to 9, so these are integers. So all we need is this path actually. Or even actually we can do that. No, because we're gonna break this. So let's copy this. Because I want to put a slider. Building generator. Let's now observe our caches. Let's put this guy here. Let's edit parameter interface. Drop in an integer. Let's call this switch. In case you need to use it somewhere else, let's call it switch. Accept. Copy this parameter and replace that building seed with this. Oh, and then the dollar $os needs to match, obviously, because it's in the file path. So we have 8 buildings, 9 buildings, not 10. Last one crashed. Let's have a look at our new assets. Okay. Okay, so these are the buildings that we will be playing with. This is 1, this is 2, a little bit more circular. This is 3, a lot more circular. This is 4, more squarish. Nice, another squarish. A short, small one. A medium-sized circular one. All right, they're all random. They kind of like 4 distinct shapes, but you scatter some of these around with different colors. It's a good start. And considering the amount of time we needed to generate these random buildings, I think it's pretty cool. Remember, they also have interiors, they have lights, so I think that's pretty cool. All right, we didn't skip anything. Everything is plugged in here. All right, I think now we can start working on the where is it, fracturing workflow. So let's drop in. Let's hide this guy. Let's save this now again, and finally I'm gonna now save as the next lesson. I'm gonna call this 06 fracturing. Whole another level of its own. Okay, I guess we can put this in primary RBD simulation section. So let's go geometry, building fracturing. Fracture. Okay, let's dive inside. So obviously this is a wedge thing again, so I think I'll just copy that guy. And this is usually the part you discover. Oh, I could have done that. Oh, I could have done this. No, I didn't copy it. No, I didn't copy it. Copy. One node copied. Confirmed. Building fracture. Paste. All right. This is my input. All right. So remember we have sections right here. So I want to blast all this into their own streams. So on the most left, I'm going to have my glass. Okay. Next, let's put this all the way here. I'm going to have my antenna. Okay. Next, I'm going to have my, what do I have? Columns. I guess this, yes. Next, I'm going to have my floors. Okay. Next, I'm going to have my frame. Okay. I'm going to have my sidewall. Oh, bugger. Okay. We have a crash. We were not even doing something crucial. Yeah. Okay. I don't know. This is like the latest build almost. These things was happening 10 years ago. Now it's also happening. It's just a blast. I have no idea why this is happening, but it happens. Good thing though, Houdini is good at recovery saving. I mean, we're gonna find that now anyway. That's why also saving is quite often. And I'm on Linux, so it's supposed to be more stable. Open crash file. Yes, please. And don't crash. Okay. Obviously this $hip won't work, so let's go file save as into our hip inferno folder. And save over. Yes. No. Let's save here as part 2. No, it's the part 1. Okay. Reload. Sidewall is not a valid group. It's not. It's just a wall. Out walls. Oh, we changed the name. Out wall. Out walls. Okay. Then we have the walls. Interior walls, right? Okay, and finally we have the shell. Okay, and we have the lights. Well, lights don't need fracturing, but we still need to pass it down to our final packaged thing. Lights. Okay, and we're gonna probably get rid of some of those. Like, I don't know why. We probably don't need all lights. I mean, every room would have a light, but you know. Okay, so that looks like a lot of work, and yes, it is, but that's important. All right, so let's fracturing our glass first. So I used Voronoi fracture for this one. Reason why is, let me give you a little presentation on that one. So I'm going to use connected. I'm just going to get one floor. Okay. So the material fracture has a nice glass fracturing tool. However, on a scale like this, these may not be very time friendly unless you can really use a big farm for each floor, let's say. So this is cool, right? But this is an entire floor, so you're gonna need like 10,000 of these. So let's go 10, not 10,000. And now it's taking a bit longer. Okay, obviously it's taking a while. Okay, and we still need at least, I don't know, 1,000 more because this is a huge glass now. So obviously this is a no-go. Now let's do a test for normal regular Voronoi, right? Let's do a Voronoi. Regular Voronoi. Let's scatter some points. Okay, let's go here, This is 1,000 and it's done. Well, yeah, obviously these are not very pretty, but if you remember my scene, our cameras, the size and the scale, we can make this work. We can go like, I don't know, 10,000 and then merge some of those back in, you know, to get a bit more jagged edges. So it's kind of a lot more, I think, feasible, because I think this will take a year to fracture with the material fracture glass feature. I think that's more like designed for smaller things. Or I mean, you can definitely, but you'll need a farm and you'll need an entire night to, you know, cook it. So it's a bit more, I would say, challenging. Next thing we can do is create a loop. I did create a loop here, I'm not sure why, and I did per primitive. Let's try. So I have a for each. Because do I have a value here? I have name, right? Yeah, so let's go with that one. For each named primitive. So it isolated automatically, and I'll do this now in here. What I want to do is just maybe change the seed, so the points change places. Okay, and what I need to do here is that I want to put this in a, oh, it's doing the entire thing now. So then we want to speed that up actually. So we're gonna put them in a compile swap as well. So let me see. So this is now the current CPU usage. Okay, so the compile swap is supposed to run these things a bit more in parallel. So my hope is to get another 30% squeeze using the compile swap. So if it's going to take 10 minutes, maybe it's going to take, I don't know, 7 minutes after the compile swap. So it's like itty bitty optimizations here and there. I think it's end of the project, it makes a big difference, and it's also good practice to keep, you know, learning things. So it's kind of going, but it's not maybe going as fast as it could. So let's handle that by using compile swaps. So compile swaps are not 100% supported with every node. The way to check that is you hit D on your network view, you go to badges, and where is it? It should be compile. I'm not seeing it. Why am I not seeing it? It's here somewhere. I'm blind. Did they remove it? No. Maybe this is child. Oh, here. Sorry. Context specific non-compilable swap badge. So you go, large. It will show you this guy, and if you have this guy, it's a problem that you may not be able to compile it, but we don't have it now. So for testing purposes, again, always testing smaller chunks. Let's select connectivity and let's select the chunk. Maybe just this top section. Okay, and now drop in a compile swap. Compile block. So this will be the input, encapsulating everything here, and this will be the output, and this guy needs to have the multi-thread when compiled on. So now if I do that, is this calculating? Where's my flag? I go here. And let's check our CPU usage. See if it did any good. It kind of didn't. No, maybe a little. Okay. Solitaire. All right. I was expecting a bit more boost. I used this in the other scene. It's kind of doing the same thing. It's not that fast either. Okay, let me kill this. Maybe we're doing something wrong. Die. Okay, let's try just like this first. Go. I wonder if it's kind of doing the same speed. Okay, maybe Orano is multi-threaded enough, or maybe we have 10,000 points, a bit too much for each floor. Okay, let's go with 1,000. And it's done. Okay, so these are generally, I think, a little too big for glass pieces, but we're gonna put a note here saying, increase for final. So it's 1,000, so we can do something like this. Manual. Oh, we also need to, I think, no, this is fine because we're doing this in the loop, so it's kind of distributing the almost same amount of, oh, it's not. Okay, yeah, so that was the problem. I think I need to use density instead of, okay, I am using the density instead of the force total count. I think this is gonna work better. So let's test that. No, just give me this one. Actually, I want to observe how much points I'm distributing per floor, and using the density is kind of gonna give me a bit more consistent distribution. So if I change that from density to force total count, then based on the size you're gonna get different distribution. So this will end up getting much more fractured points, so we don't want that. So let's turn off the force total count again. When you turn that off, density gets enabled. Then you'll end up with, let's say, here this guy's gonna get 1,000 glass pieces. So if I do if I have a look at this now, so that's maybe a little too much for testing purposes. Let's go 5, a little reasonable. Okay, let's go, let's get that cooked for all the floors we have. Okay, it's going, not all the floors, but our test section. Almost done. Okay, so because now we're not changing our seed, you're gonna see that if these objects line up, you're gonna see the exact same shapes. So we need to randomize our seed, right? So I want to randomize that. We can do a lot of things. We can randomize based on the iteration value, or let's try something else today. Let's try the length of the centroid. So let's guess for each, you know, one of these, we get the first point, and we're gonna get the centroid of this shape, and we're going to get its position's length and use that as a random value generator, as a global seed. So how can we do that? We can say, so I'm going to put a null here. Okay, it's going to go here, and I'm going to say in glass, just another way of doing random things. I don't need the iterations, it's going to be a bit faster. So the seed will be based on centroid, right? And then we're pointing it to in glass now, right? And that will be, this needs to be closed now, comma dx. So that should get me the centroid value of the x-axis. Okay, which is somewhere at -5, probably accurate. Now copy this. Oh, sorry. And I want to get the length. Remember, so the length needs 3 attributes. So length x, y, z. Right. I'm gonna copy this, comma y, comma z, then finally close this. It's going to return me a value. That value is now my seed, which means now every floor should get a different fracture pattern. Okay. Let's have a look. If we check the same place again, okay, so here to here, you know, it's kind of different. All right, so I still want to pass this through Voronoi, and I actually, compile, and actually want to be able to measure that. So let's do that. I'm not happy about it. So let's copy paste this. Let's measure it anyway. Maybe we get a little gain. Oh, we should have saved. Oops, something's happening. All right, it's working. Let's save. File, save. Okay, in glass 1. So this, the cool thing here is that I really like what Houdini does. Like it copied, it updated this to glass 1, which is here, and it's really cool. So let's pass this one from the compile swap. Let's put it on manual. This guy goes here, this guy goes here, right? And this now, when compile, it's gonna stay on. So now the thing is, if I try to run this as it is, it should error. It's going to say there's some references internally being done, and you cannot do that. I think I'm in here. It's in my other window. Let me bring this in here. Okay, internal reference. So you cannot make internal references like calling information from other nodes. in compiled subs. These are managed by spare parameters. This is explained quite well in documentation. If anything, I think probably I should bring that up here so you guys can see it as well. If I let me see if we can find it through here. Okay, let it load. Block compiled. There should be something somewhere. Block in compiled blocks, maybe here. It's well explained in the documentation. I'll open it and then I'll show it from here. As it is not. Come on. Not the compile and compile block. Okay. Let's try searching it. I think the online documentation works better. Let me load it in Houdini. Houdini 18.5 docs. Okay, let's go compiled here. Compiled blocks. Invoke compiled blocks. Not 16.5. I don't know why this is so hard to use. Block begin. Seriously, okay. Let's go through the last one. Then go down here. Let's go to compile, and hopefully we're gonna find this guy, and this one works better. Okay, here, compile block. So have a read this. Have a go. It's quite useful. There's a lot of good information, and the part now we're focusing on is the spare inputs, and this is what I'm basically showing now, how to make references. So it works. So on your node that you are referencing things, we need to put a spare parameter here. So if you click on the gearbox, you can click on add spare input, and that's actually quite simple. Then you will drag this guy and drop it there, and basically this spare input 0 now is represented by a -1 and instead of an actual path. So you just type here -1, and that's really it. I don't know the math behind it, but it works. There's one more here. Okay, now it should execute itself. It's doing something. Okay. So the update wasn't very live, but it kind of went through. So the only thing I think we can do now is put a merge here, and I guess say put a null. We're gonna measure this. Compiled. Non-compiled. I'm going to reset. I'm gonna merge these here. Put the flag here. Performance monitor. Record. And I'm going to. Sorry, let's do it a bit better. We're gonna do the whole thing. I'm gonna disable the selection, so it's gonna do the entire building. Okay. Record. Auto update, and now it should kick in. So this is probably gonna take a few minutes. So I'm gonna pause and come back once the results are out.